Kia ora, Year 12. This short video is going to go through how to write your plan for 213 simulations. So I've done a really simple simulation here, and I've, as usual, stolen it from Mr. Griffith's lovely workbook. So I've changed a couple of words, that's about it. What I want you to focus on here is making sure that you integrate the context with the kind of numerical random number stuff really well right through this, and that you think about the kind of little tricky things that are in the context about what we're trying to work out. Okay, so let's just go through the question. Over the next month, Pack and Spend is giving away one of 10 Lego mini sets to each customer who spends at least $40 at the supermarket. Sam estimates that he will spend $40 6 times this month. He is interested in knowing what is the probability that he gets 2 of the same toy in his 6 supermarket trips. Okay, so you can see from looking that there are no probabilities given. There's nothing really very complicated about this situation. There are 10 Lego mini sets, and so when we get onto the actually doing the simulation and thinking about the assumptions, I'm just going to assume that those 10 mini sets have equal probabilities of occurring, and we can play around with that, but that's going to be the basic assumption. The other thing to notice here is that he's going to the supermarket 6 times this month. Well, he's spending $40 6 times this month, so you know that one trial is going to have 6 goes in it. Lastly, he wants to know about the probability of getting 2 of the same toy in his 6 supermarket trips. So we're going to have to think about what we want to do with situations where he gets 3 of the same toy. Does he really mean that he gets at least 2 of the same toy, or what? So I've made a couple of assumptions on that, but I could do this a few different ways. I've put in here the acronym that I've made up to help you remember what you need to have in your plan. So pause the video here and just jot down what each of those things are. So the first one is tool. The second one is how we're going to do our allocation using our tool, how we'll get some numbers or outcomes there. The next thing is what is one trial, and how many trials am I going to do? Then S stands for what do I mean by a success, right? And that's where I'm going to talk about what 2 of the same toy means. R and K are easy. R is how do I record my stuff, and K is the key. So what I've done here is I've just typed in before I made the video what I would put for a good plan for each of these things. So here's what I said for tool. I said I'm going to use a graphics calculator to generate random numbers between 1 and 10, and I'll use randint 110 to do this. Now, if you think about why I've used 10, it's the lowest number that I can get away with. I've got no information to suggest that any toy is more common than any other toy. So we're assuming equal probabilities, and that means that I've got these 10 possible toys, and they've got equal probabilities. So in this situation, deciding which random numbers to give to which toy is really easy, right? So that's the next step. That's tool, the calculator bit. Allocation, right? Well, I'm going to choose the random numbers to match up to the probabilities. So we're just going to use random number 1 will be toy 1, 2 will be toy 2, and so on. The next thing to think about is whether we're going to have repeated numbers in my simulation. And I definitely want to do that here, because in real life, that's kind of what I'm interested in, right? I'm trying to work out the probability that Sam gets 2 of the same toy on 6 trips to the supermarket. So I have to put repeated numbers in. The whole thing totally doesn't make sense if I don't do that. Right, now let's talk about what one trial is and how many trials I'm going to do. One trial means one go that matches up to what happens in real life. So here, one trial means 6 random numbers. 6 random numbers match the 6 trips where I spend at least $40. So notice that I'm linking up my context with how many numbers I've got. So one trial might just give me these 6 numbers, 4, 6, 7, 6, 8, 1. Next, no matter how quickly he gets a double, I'm still going to do 6 numbers in one trial. And that's because Sam would presumably keep going to the supermarket, right? He's not going to stop buying food just because he's got his little minifig. And lastly, I need to say that I'm going to do however many trials. Now, I've gone with 30 here. That's the absolute minimum number, but that should be enough to see patterns in the results. And it's not going to take me too long. So what have I done now? Well, I've done tool, allocation, and now I've done trial. Next up, I've got success, recording, and key. Now, these ones are pretty easy. Success and trial and allocation are the three where students tend to come a little bit unstuck. So what I mean by success here means getting 2 of the same toy, but I've also included getting more than 2 of the same toy. Now, you could argue about that. I'm thinking about that, looking back now again, looking back at the question, I actually have been asked specifically for the probability that he gets 2 of the same toy, not like 2 or better. So I'm going to change my mind on this. I'm crossing this out. It means getting exactly 2 of the same toy. Now, if I get 2 lots of doubles in one trial, I'm just going to count this as one success, right? So say I get 6, 4, 5, 5, 7, 4, then I've got my success because I've got 2 of the same toy, right? I've also got another 2 of the same toy, but that's just going to be a success with a tick to say success. If I get 3 of the same toy, suppose I get 6, 4, if I get that, I've decided that I'm actually going to count that as not a success in this case, right? Because I haven't been asked about 2 or more, haven't been asked about 3, I've just been asked about 2. I could do a follow-up thing from my table and work out how many 3s I had, but we'll keep it separate. Okay, so I'm counting success as exactly 2 of the same toy in my 6 trips. Right, so hopefully what you're seeing is that you really do have to think quite hard about what they want, what real life means here, and what we're trying to measure. Right, so in this case, going back to the question again, it's the probability that Sam gets 2 of the same toy. So that's success. And now I'm going to talk about recording. Okay, I'm going to record my results in a table, and the table will look roughly like this. So I've done it here as just having the trial number down here, the numbers here, and then I've got success, yes or no, and comments. Now, I'm just looking at this, and I'm deciding that here this is okay, right, for my recording, because 5 means toy 5. So I think it's pretty obvious with this table when I've got a double, right? So in this one here, I've got 5, 8, 2, 3, 1, 4, so success, no. In here, I've got a 4 and a 4, so I've got the success, yes. What I've got to do last is say, what is my key? And this is probably the easiest one that we've done in the last couple of weeks, because the key here is so basic. It just means that number 5 is toy 5, number 6 is toy 6. So the key here is really easy. 1 is toy 1, 2 is toy 2, and so on. Dot, 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 and so 10 is equal to toy number 10, or Lego toy number 10. So that's how you do your plan. If this video has been useful, let me know, and I can do some videos on some harder examples. But if no one watches it, I probably am not going to bother. So please just give me some feedback either way on whether this has helped. Thanks for watching, and I'll see some of you in class tomorrow.